A metal strong enough for jet engines, but light enough to wear on your face. How is that possible? Imagine this. A metal so strong, it can survive inside a jet engine, yet so light, you can wear it on your face every day. A metal that doesn't rust in seawater, that doesn't get rejected by the human body, that can literally become part of you. It sounds like something from science fiction, but it's real. And for most of human history, we had no idea it even existed because this metal was hiding in plain sight, inside sand, inside rocks, right beneath our feet. Its name, titanium, and its story is far more complicated than you think. Back in the late 1700s, in a quiet corner of England, a man named William Gregor noticed something strange. Black sand, heavy, unusual, different from anything he had seen before. When he studied it, he realized something incredible. It contained a completely new element, but no one paid attention. Years later, another scientist, Martin Heinrich Klaproth, rediscovered it. And this time, it got a name. Titanium, named after the Titans, the powerful giants of mythology. A fitting name, because this metal promised strength beyond anything known at the time. But there was one problem. No one could actually use it, because titanium didn't want to be extracted. Unlike gold or silver, you don't find titanium sitting freely in nature. It's locked inside minerals, hidden, trapped. And the moment scientists tried to extract it, it fought back. At high temperatures, titanium reacts violently with oxygen. Instead of becoming useful metal, it turns brittle, weak, useless. For over a century, titanium remained just an idea, a powerful metal that humans couldn't control. Until the 1940s, a man named William Justin Kroll changed everything. He developed a method to extract titanium in a controlled environment. Now, for the first time, titanium could be produced on a large scale. The sleeping giant had finally awakened. But even then, the process wasn't simple. It still isn't. Titanium doesn't start as shiny metal. It begins as ordinary-looking ore, found in places like Australia, South Africa, and Canada. Rock, sand, nothing special at first glance. But inside, something extraordinary. The ore is treated with chlorine and carbon, transformed into a dangerous liquid, then heated again, mixed with magnesium, inside a sealed environment, and slowly, it turns into something strange. A porous gray material, called titanium sponge. It doesn't look impressive, but it is pure titanium. From there, it's melted, refined, shaped, into the metal we recognize today. And after all that effort, what makes it worth it? Why go through so much trouble? Because titanium does something almost no other metal can. It combines strength with lightness, nearly as strong as steel, but almost half the weight. That's why airplanes rely on it, why spacecraft depend on it. Because in flight, weight is everything. Then there's corrosion. Water destroys most metals. Salt water destroys them even faster. But titanium, it doesn't care. It resists rust, survives oceans, endures harsh environments. That's why it's used in submarines, ships, offshore systems, and then, the most surprising property of all, the human body accepts it. No rejection, no reaction. Doctors use titanium for implants, artificial joints, dental screws. It doesn't just exist outside your body. It can become part of you. And finally, heat. Extreme heat. The kind that melts most metals. Titanium survives it. That's why it's used in jet engines, where temperatures are brutal, unforgiving. Put it all together, and titanium isn't just another metal. It's a super material. Strong, light, resistant, compatible. But it comes at a cost. Because even today, titanium is expensive to produce. The process is complex, energy-intensive, difficult, But scientists are working on it, trying to make it cheaper, cleaner, more accessible, because if they succeed, everything changes. Cars become lighter, buildings become stronger, space exploration goes further. Titanium's story is not finished. In many ways, it's just beginning. So the next time you hear the word titanium, don't just think of metal. Think of something that spent centuries hidden in sand before becoming one of the most important materials on Earth. Because sometimes the most powerful things are the ones we couldn't see. Imagine a metal so strong it can survive inside the burning heart of a jet engine, yet light enough to rest comfortably on your wrist. A metal that refuses to rust, even when submerged in seawater for years, and is so compatible with the human body that doctors can place it inside you without rejection. It sounds like something engineered in the future, but it's real. It's titanium. And here's the strange part. For most of human history, no one even knew it existed. The story begins in 1791 in the quiet countryside of England. A clergyman named William Gregor was studying black sand near a small stream. At first glance, it looked completely ordinary, the kind of material you would ignore without a second thought. But something about it felt different. It was heavier than expected, slightly magnetic, almost as if it was hiding something. Driven by curiosity, he decided to investigate further. What he discovered was remarkable. Traces of an entirely new element, something no one had ever identified before. He named it after his village, calling it Monaconite. It should have been a breakthrough moment, but it wasn't. At the time, the world had no use for such a discovery. There was no industry waiting for it, no technology that required it, no reason for anyone to care. And so, despite its potential, the discovery faded into obscurity. The metal remained hidden, not just in the earth, but in human awareness itself. For years, titanium existed as a forgotten idea, quietly waiting for someone else to uncover its true power. A few years later, in 1795, the same mysterious element was rediscovered, this time by a German chemist named Martin Heinrich Klaproth. Unlike before, this discovery didn't just stop at observation. Klaproth saw something more in it, something powerful. He chose not to keep the old name. Instead, he gave it a new one, titanium, inspired by the titans of Greek mythology, the ancient giants known for their immense strength. It was a bold name, a powerful name, a name that suggested this metal would one day become something extraordinary. But reality didn't match the name, because despite its promise, titanium remained locked away. Unlike metals such as gold or iron, it is never found in pure form. Instead, it hides deep inside stubborn minerals like rutile and ilmenite, bonded tightly with oxygen in a way that makes it incredibly difficult to extract. And that created a frustrating paradox. The metal was there. Scientists could see it, they could measure it, they could name it, but they couldn't use it. Every attempt to isolate pure titanium ended the same way. The moment it was exposed to heat and air, it reacted violently, turning brittle and unusable. Instead of becoming strong and useful, it crumbled apart. So for more than a century, titanium remained exactly what its name promised, a giant, but one that was completely trapped. For over a century, titanium remained one of the most frustrating mysteries in science. Researchers knew it existed, they knew it had incredible potential, but no matter what they tried, they couldn't control it. The problem was simple, and nearly impossible to solve. Titanium doesn't behave like other metals. The moment it's exposed to high temperatures, it reacts aggressively with oxygen, nitrogen, even hydrogen in the air. Instead of becoming stronger, it turns brittle, fragile, and completely useless. Again and again, scientists attempted to isolate it. And every time, it failed. Small samples would form, only to crumble apart. Promising experiments would collapse at the final step. Titanium wasn't just difficult to extract. It actively resisted being turned into something usable. For decades, It remained exactly what it had always been: hidden potential, untouchable strength, a material that existed but couldn't be harnessed. Until the 1940s. That's when a metallurgist named William Justin Kroll introduced a method that changed everything. Instead of fighting titanium in open air, he worked in a controlled environment. By reacting titanium compounds with magnesium inside a sealed system, he was finally able to isolate the metal in a stable form. This became known as the Kroll process. And for the first time in history, titanium was no longer a mystery. It was a material, something that could be produced, shaped, and used. After more than 100 years of failure, the sleeping giant had finally been awakened. To understand why titanium is so valuable, you have to understand how difficult it is to make, because titanium doesn't come out of the ground as shiny metal. It begins its journey hidden inside ordinary-looking minerals, mainly rutile and ilmenite. At first glance, these materials look like nothing more than dark sand or dull rock. But inside them lies one of the strongest metals on Earth. Once the ore is mined, the transformation begins. The first step is chemical. Scientists treat the material with chlorine and carbon at extremely high temperatures. This converts the solid ore into a strange, clear liquid called titanium tetrachloride, a compound that looks almost harmless, but is highly reactive and must be handled with extreme care. Then comes the most critical stage. Using the Kroll process, this liquid is heated with magnesium inside a sealed chamber. As the reaction unfolds, something unusual forms: a porous, sponge-like material known as titanium sponge. It doesn't look impressive, not shiny, not smooth, but this is pure titanium in its rawest form. Finally, the sponge is melted inside massive vacuum furnaces. This step removes any remaining oxygen or impurities, allowing the metal to reach its true strength. From there, it is cast into solid forms: ingots, sheets, rods, and wires, ready to be used across industries. It's a long, complex journey, from sand to liquid to sponge to metal, and every step has to be controlled with precision. Because with titanium, even a small mistake can ruin everything. After everything it takes to produce titanium, you might wonder, is it really worth it? The answer is yes. And the reason lies in something incredibly rare. Titanium doesn't just have one advantage, it has all of them. First, it's incredibly strong. Not just strong in a general sense, it has nearly the same strength as steel, but without the massive weight. In fact, titanium is about 45% lighter, which means engineers can build structures that are just as durable, but far more efficient. And in industries like aerospace, that difference changes everything. Less weight means less fuel. More speed, greater performance. But strength alone isn't enough. Titanium also resists corrosion in a way almost no other metal can. While steel rusts and weakens over time, titanium forms a natural protective layer that shields it from water, salt, and even harsh chemical environments. That's why it's trusted in submarines, ships, and offshore structures, places where other metals simply wouldn't last. Then there's something even more surprising. The human body accepts titanium. Unlike most materials, it doesn't trigger rejection or allergic reactions. Instead, it integrates naturally, allowing it to be used in medical implants like artificial joints, dental screws, and surgical tools. In a way, it becomes part of you. And finally, titanium can withstand extreme heat. Temperatures that would weaken or destroy other metals have far less effect on it, making it ideal for jet engines, spacecraft, and high-performance systems. When you combine all of these properties together, you don't just get a strong metal, you get something unique: lightweight, durable, resistant, biocompatible, heat-tolerant, a material that checks every box. And that's why, despite the cost, titanium isn't just used, it's relied on. So the next time you hear the word titanium, don't just think of metal. Think of a journey, a material that spent centuries hidden inside ordinary sand, unnoticed, unused, and impossible to control. A discovery that was ignored, a name that promised power long before it could be proven, and a century of failure before humanity finally learned how to unlock it. Because titanium isn't just strong, it's earned that strength through chemistry, through engineering, and through time. Today, it flies in the sky, dives into the deepest oceans, and even exists inside the human body, thus quietly supporting the world in ways most people never see. And the most interesting part? We're still just getting started. Thank you for watching. If you enjoyed this story, don't forget to like, share it with someone who loves science, and subscribe for more hidden histories behind the world around you.